All right, welcome to Chapter 4, Section 4, called Linear Functions. This is for Math 8. So just to go over the screen here, a few of the features. You should see a due date before attempts here. I don't see it on the teacher preview, but you will see it on your screen. For attempts, we always allow unlimited attempts. You can come in and submit this assignment as many times as you would like. This particular assignment has 6 questions. Just kind of depends on the section how many we'll have. Grading policy is best score, so whichever attempt is the best one is the one you get to keep. And partial credit is enabled, so if you answer 1 of 6 questions, you get credit for that one question. This reminder down here just says, remember once you start working on your homework, you have to finish it before you can start anything else. What that means is once I click start, down in the bottom right corner of your screen, you will see a submit assignment button. When you're ready to leave the screen, whether or not you have finished all of the questions or even started them, right now you're ready to leave the screen, you click that button. It does 2 things. Number 1, it stops the system from locking you out of all your other assignments, just like that statement said, and it lets your teacher see what you've been working on. So it also affects the gradebook when your teacher can see what you've been working on. Otherwise, it kind of just freezes it. It locks it out. So always, always, always click that button. Over here, we have explanation, example, and message center. Explanation tells you you're going to lose your question attempt because it's going to give you the solution to this exact problem. So it's not going to give you the solution and then let you come type in the answer. You're going to have to come back in and try that on another attempt. Example does give us an example of exactly what it wants us to do. So here's an equation, here's a table, and then once we create our table, we can graph our points and plot our points and graph our line. So you can close this, you can open another example if you want, and then you can also message your teacher right from this screen, attaches a picture so we know exactly where to come help you. All right, so this is a little bit of a review. We've been doing this for a little while now where if we get an equation, the first thing I make my students do in class is make a table. Make a table to organize your coordinates, and I even go a little farther so that it's like this, and I have the calculation here in between, so that it's very easy. We can just keep all of our work together. And I know on the notes pages when we do this, I tend to have the tables created for at least a couple of them, and then I have students start creating them on their own. So we get to choose inputs. They're not choosing them for us. So we want to choose a couple, and I tend to choose some small ones just because it makes it a little easier to graph. The only thing you want to be careful about is the size of the window here. If I choose larger inputs, it's not that they're wrong, but if I choose something that gives me more than 9, because I can't even go all the way to the 10 mark here, so anything bigger than 9, I can't graph. It won't let me graph it on the system. It's not a wrong coordinate, it's just too big for the graph. So just be aware of that. All right, so in here we're going to have our pieces, and I'm going to kind of put them in here like this, and I'm going to put the inputs. So we chose 0, I chose 1, and then I chose 2. So these are the calculations, and think of this like a little machine. We have an input, here's our calculation area, and then we have our output. So input, output, and here's our calculate. So this is like our machine happening here. It's calculating, it's going to output some numbers. So I know it's a little silly, but this is the idea. We have an input and we have an output. So if I input 0, I get 0, because 3 times 0 is 0. If I input 1, 1 times 3 is 3. If I input 2, I get 6. So remember, these are coordinates. This is 0, 0, and I crossed one off and not the other. So we have 0, 0. This one is 1, 3. And sometimes for students it's a little easier if we actually write these out like this, so you can actually see the coordinates. Remember, a coordinate system is just telling us how to get around. So if we kind of pretend like this is the center of a city and I want to get to different points, I have to decide how am I going to get there. Well, 0, 0 means I don't move from the center, so I'm already where I want to be, right there. This guy is telling me that I'm going to move to the right. I always move right or left first. Positive is right, negative is left. If we're thinking about, just a basic number line here, positive, negative. And then when I go to the next number, we can either go up or down. So again, up is positive, down is negative. So since it's positive, I'm going to go up. So from this point, and I always go back to the center, even though, yes, that's where I'm standing from the first point, but I always go back to the center, and I'm going to go right 1 and up 3. There, I'm at the next point. So I'm going to go back to center real quick, and I'm going to go over here. Now I'm going to go right 2 and up 6. I'm going to go right 2 and up 6. So I'm kind of giving directions from this point. How would I get from here to here? I would go right 2 and I'd go up 6. Always right or left first, then up or down. So it's just the directions that we always do. We don't go up first and then right. That's not how the direction system works. So always left or right and then up or down. Uh-oh. Oh, I forgot to connect the line, I think. Is that what I forgot to do? Doop. Ha ha ha. Graph the line. That was the main task there. I forgot to connect it. So don't forget to connect your line there. All right. So we're going to do the same thing here. Let's see if I can. Ooh, that would erase way too much. I'm just trying to be a little bit simpler there instead of going through and do the whole thing. So now we have 2x minus 6. Oop. So 2x minus 6 is going to be our compute area. I can still use these same points. That's not going to hurt anything. So I'd have 2 times 0 minus 6, 2 times 1 minus 6, and 2 times 2 minus 6. So I'll put the numbers in there in red just so we can see. Here's our input. And then we're going to go through and calculate our output here. So 2 times 0 is 0. Minus 6 is minus 6. So it's 0 minus 6. That's where I got negative 6 here. 2 times 1 is 2 minus 6. So they're opposites. I'm going to subtract. I have more negative than positive, so it's going to be negative 4. 2 times 2 is 4 minus 6. So I'm going to subtract again. And 6 is still the bigger number out of 4. There's still more negative than positive. So now I have 0, negative 6. That's my first coordinate. Second coordinate is 1, negative 4. And 2, negative 2 for that other one. So I'm going to go over here and I'm going to start plotting. So 0 means I don't go right or left. Negative 6 means I go down to negative 6. So I went down. So I stayed. I didn't go right or left, but I do go down. For 1, I'm going to go positive 1 to the right and negative 4 down. For 2, I'm going to go positive 2 and negative 2. So again, this is just a little quick direction system so you can kind of remind yourself these are the directions I'm going. Go down, right 1, down 4, and then I'm going to go from here, I'm going to go right 2 and down 2. So always go back to the center when you're doing this. And then don't forget, like I did on the last one, to actually graph the line. Ha ha ha. All right, so now we're going to do a fractional one. All right, and you can just keep reusing the same idea, the same tables. I know you probably don't have the option to erase all of it like I do because I have this digital whiteboard, but can still work somewhat the same there. All right, so now I have negative 1/4 times x plus 3. This is going to take a little bit more room, but that's okay. I think I'm going to erase my machine here just so I have room to write some of the calculations underneath. Okay, so we're going to go with 0, 1, and 2. All right, so I have negative 1/4 times 0, so that gets me 0 plus 3. 0 plus 3 is 3. So my first coordinate is 0, 3. My second one, I already know my inputs, by the way, because we already chose them. And you can choose other numbers. You don't have to keep choosing 0, 1, and 2. I'm just, for whatever reason, choosing those numbers. So now I have negative 1/4 times 1. Well, that's going to get me negative 1/4, and then I have to add 3. There's one thing that we could do on this one that would make it a little bit easier so we end up with integers. If you multiply by something that's a multiple of 4, it'll eliminate the fraction. So instead of multiplying by 1, I'm actually going to change this guy to 4. So I'm going to change my input because 4 divided by 4 gives me 1. That's what this looks like when I go like this. Times 4, it's like this. So I'd end up with negative 4 over 4. So negative 4 divided by 4 gives me negative 1 plus 3. So negative 1 plus 3, that gives me positive 2. So that's a little easier to graph, or a little bit easier to combine, because the other one I would have had 1/4. I'd have to add 3 if I multiplied by 1, if I had left it 1. And now I'm going to have to change, this bottom is a 1, but I'm going to change it to a 4, which means this will be a 12, and then I'd end up with 11/4 that I'm going to have to graph, which is possible. You can use plot a point tool and you can plot a fraction. That's fine. But I think it's a little easier if we choose numbers that are divisible by 8 or by 4. So the first one was 4, and instead of 2, I'm going to go with the next factor of 4, the next multiple. I'm going to go with 8. So I'm going to change this to 8. So now I have -1/4 times 8. Remember, there's a 1 underneath. So that would give me -8 on top and 4 on the bottom. Well, -8 divided by 4 is -2 plus 3. So -2 plus 3 is 1. So now I have coordinates that I can plot pretty easily. Again, if you end up with fractions, not a big deal. You can still do that. And we can still do our direction system here. I'm not going to move, but I'm going to go down. I'm going to go right 4, up 2. I'm going to go right 8, and up 1. So I'm going to go up to 3, go back to center, go over 4, up 2, go back to center, go over 8, up 1. Boom, boom. So if you ended up with fractions, and I can even show you on this one, so if we left it 1, the output would have been 11/4. Hopefully I calculated that correctly. And we can even see it's happening right there. So I can click plot a point, and it's on the line. It still works. I could have used that point. It just depends on if you want to mess with fractions or not. And I know a lot of my students try to avoid that if we can. All right, next. Okay. So with this one, it says Tony needs to read 3 novels each month. Let N be the number of novels Tony needs to read in a month. In M months. Write an equation relating N to M. All right. So if N is the number of novels that Tony needs to read in M months, he's reading 3 novels each month. Each month tells me I'm multiplying by months. So I know it's going to be 3 times the number of months. I already know that. So that's going to be part of my equation. 3M, 3 novels per month. And the total number of novels that he reads depends on how many months he's been reading. So instead of using Y, they want us to use N. So the total number of novels is going to equal 3 times however many months he's been reading. We don't know how many months he's been doing this so far. So this relates N to M. 3 novels every month. So in the first month, he'll have read 3 novels, right? 3 times 1. In the second month, he'll have read 6 novels, 3 times 2. So we can see this pattern start to happen here. So with this one, what we want to think about is, where is Mr. Tony starting? At the very beginning, has he read anything at all? And the answer would be no. So at 0 months, he would have read 0 books. At 1 month, he should have read 3 books. At 2 months, he should have read 6. So if you notice, it's going up by 3 each time. At 3 months, he should have read 9. And we can see this line going up. So now we can even connect it. We don't need to do all of these, because this line will help show us this pattern. If I go to 5 months, then he should be up here at, it should be at 15, but we can't quite see 15 up there, so it'll be a little higher here above the chart, because this goes to 14 right here. So it'd be right above the chart. But if I go to 4, then it's at 12. So that makes sense. 3 times 4 is 12. So at 4 months, he should have read 12 novels. He's definitely reading a bunch. That's awesome. All right, let's see. Okay, the Sugar Sweet Company is renting a truck. So I know we did this one in class too. I remember this guy. They like the Sugar Sweet Company example. Okay, so the Sugar Sweet Company is going to transport its sugar to market. It will cost $5,000 to rent the truck. And it will cost an additional $200, and I'm going to say per ton. It says for each ton, but I'm going to just say per ton, just to kind of shorten that. Per ton of sugar transported. So from that first sentence, or two sentences, I grabbed 2 bits of information there that were important. It really doesn't matter what we're transporting or how we're transporting it. What it matters is how much does it cost us to start with. It costs us $5,000 just to rent the truck. And then there's an additional cost for each ton of sugar. Each tells me that it's a multiplication word. So per ton or each ton, if we could put each on there, that would still do the same thing. So it's going to be an additional cost. We're going to let C be the total. So C is what our output is our total. And we're going to let S represent the tons of sugar. So it's going to be times S instead of per ton. So we're going to write an equation relating C to S. So we've already basically done this. We just need to put it down here into an actual equation. So we start with $5,000 and we have to add 200 per ton. So times S, like that. And sorry, I know I crossed my S's like that because I'm told they look like 5s. So I've just started writing them that way. So I have C equals our starting point, $5,000, plus 200 for every ton. Oop, not 2,000, 200 for every ton that we actually transport. So definitely a bit expensive to transport sugar here. So now we're going to graph it. So if we go back, we want our starting point. Remember, this is where we're starting. So the starting point is our y-intercept. So we can go to the y-intercept here. And I don't like how that's working. There we go. I had scooted that over so it wasn't tracking correctly. So we can go up here and click. This is our starting point. Our starting point's not 0. We're going to start at 5,000. That's the minimum amount we have to pay, 5,000. And then if we transport 1 ton of sugar, so 1 ton of sugar here, like this, we have our 5,000 plus $200. So it's going to be 5,200. Now if you notice, I can't plot 5,200 with my pencil tool. It's not going to let me. It's either going to 5,000 or 5,500. So I'm going to click on this plot a point tool and say if I transport 1 ton of sugar, then it's going to cost me 5,200, like that. And then I can click plot a point, and I have to make it go away so I can actually see it. So there we go, it plotted it for me. Now that it's plotted, I can click on it. This tracking system is a little messy. There we go. So I wouldn't have been able to click on it if it wasn't there, but because I placed the point, it's letting me snap to that line, or that point. So it's letting me do it. But it wouldn't have let me do that if I didn't have the point there already. So just be aware of that. The system can be a little glitchy with that. But it will let you plot it once, or graph the line once you've plotted the point. All right, we have one more of these guys. Okay, so we're going to graph the function. So we've kind of talked about function notation already. Function notation just is another way of saying why. It just makes us, by giving function notation, we know that there are certain rules that come with the function. But we can just simply write it as y if that makes us feel a little better. And what we want to do is choose at least 2 points to input so that we can graph this line. So kind of a little table here. So I have x, I have y, and I'm just going to use this equation here right in the middle. So I'm going to go 0 and 1. So I'm going to have 2 times, and I'll put 0 in there in just a second, and I'm going to have 2 times 1 minus 7. So now I'm going to have 0 and 1. So if I have 0 put in here, 0 times 2 is 0, minus 7 is negative 7. 2 times 1 is 2, minus 7, so I need to subtract them, and the bigger number decides my sign there. So now my 2 coordinates, I'm going to have 0 and negative 7. That's my first one. 0 was my input, negative 7 was my output, 1 and negative 5 for my second point. So I can go ahead and graph these. I only need 2 points to graph a line. A lot of the time I make us do more than that in class because it helps us see the line before we actually graph it. So I'm not going to go anywhere from center, but I'm going to go down. I'm not going to go right or left. I'm just going to go down. And then from center, I'm going to go right 1, down 5. So I'm going to go just down to 7 and place my point. That's my y-intercept. That would actually be my starting point in this case. And we can even identify that right here. -7 is the y-intercept in the graph there. And now I'm going to go back to center and go over and down and plot my point. Now I can click and click, and I have my line graphed. All right, so that was section 4. I will see you in section 5.